Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is coordinate geometry. So what is coordinate geometry? It is sort of link between algebra and geometry. Through coordinate geometry we can visualize the figures in proper proportion. In this technique we can find the distance between points. We can compute area of different shapes and polygons. In this particular figure, we are defining a point P whose coordinates are x and y. So here x is the abscissa and y is called the ordinate. O is the origin whose coordinates are 0 and 0. Here we define the distance formula. There are 2 points A and B whose coordinates are x1, y1 and x2, y2. We want to find distance between A and B. The distance is given by AB equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. An alternate distance from origin, suppose we want to compute the distance from O to B. Then we need to put x1, y1 equal to 0 since coordinates of origin are 0 and 0. We get OB equal to square root of x2 square plus y2 square. Here we give an example. The coordinates of the end points of a diameter of a circle are A and B whose coordinates are given -2, 3 and 4, 1. Find the coordinate of the midpoint of the circle. For easy visualization, we have drawn the circle, we have defined points A and B. We want to compute coordinates for the center C. The coordinates of the center are given nothing but by x1 plus x2 by 2 and y1 plus y2 by 2, -2 plus 4 by 2, -2 and 4. Similarly, 3 plus 1 by 2, we get 1 and 2. The coordinates of the center are therefore 1, 2. Another example here. If two vertices of an equilateral triangle are -5, 3 and 5, 3, then find third vertex if origin lies inside the triangle. Here we have defined two vertices A and B as -5 by 3. This point is -5 by 3 and this is 5, 3. We want to find the third vertex of this equilateral triangle. Please note that y ordinate is 3 for both the points. So this line is parallel to x-axis. And the perpendicular bisector, since this is -5 and +5, the perpendicular bisector passes through the y-axis. Let us find distance AB. Through distance formula, we can compute distance AB as 5 minus -5, which is +5 the whole square, plus 3 minus 3 the whole square. 10 square root will be 10 only. Since this is an equilateral triangle, AB will be equal to BC equal to CA equal to 10 units. Note that we could have drawn triangle up also, but in the problem it is given that third vertex lies inside the triangle, inside the origin. So origin has to be here. So equilateral triangle cannot be drawn on the upper side. Now we compute this distance PC as this distance is 5 and this distance is 10. We can compute this PC distance as 10 square minus 5 square. So 100 minus 25, 75 square root. Square root 75 can be written as square root 25 into square root 3. Square root 25 is 5. So we'll get 5 root 3. In the y-axis, x coordinate is 0 and this distance is 3. and total distance is 5 root 3. So this particular OC we want to compute, which will be 3 minus 5 root 3. So this is the coordinate of C. Let us come to section formula now. In the distance formula, we computed distance between A and B. But in section formula, we want to find the coordinate of a point P such that it divides the line segment AB in the ratio m1:m2. The coordinate of point P is given by m1x2 plus m2x1 by m1 plus m2, and the y coordinate is given by m1y2 plus m2y1 by m1 plus m2. As a special case, if instead of dividing the point P in the ratio m1:m2, if we divide it in the ratio k:1, so we put m1 equal to k and m2 equal to 1. We simplify the previous expression as kx2 plus x1 by k plus 1, ky2 plus y1 by k plus y1. Let us solve few problems now. In what ratio does x-axis cuts the line segment joining the points A 3, 6 and B minus 12, minus 3? Let the ratio be k:1. Here x1, y1 are 3 and 6, x2, y2 is minus 12 and minus 3. We substitute those values in this particular equation. And please note that in the x-axis cuts the line segment. At x-axis, y value is 0. So we have written it as x0. So on substituting these values, we get the coordinate as minus 12k plus 3 by k plus 1 and minus 3k plus 6 k plus 1. Now since y is 0 at x-axis, this particular value goes to 0. So minus 3k plus 6 by k plus 1 equal to 0. Cross multiplying k plus will go there and become 0. So minus 3k plus 6 equal to 0. On simplification, k will be 2. So the required ratio is k:1, that is 2:1. In case it is required to find the point of intersection, then we can substitute k equal to 2 in this particular part. So minus 12 into 2 minus 24 plus 3 minus 21 by 3, which is minus 7. So the point of intersection of x-axis to this line segment will be at minus 7, 0. Another example, we want to find the coordinates of a point P such that it cuts line segment AB in the ratio AP by AB. AP by AB is given as 3:7. Our standard formula says we need to get AP and PB, but here AP by AB is given. Please note AP is 3 and AB is 7 units. AB is 7. So PB will be 4 units. So we have to write in the proper standard form. Then only we can apply the formula. So AP is to PB will be 3:4. X1, Y1 will be 3, 6. X2, Y2 will be minus 12, minus 3. And now we substitute to get coordinate of point P. So we are putting in this. We get PXY as minus 24 by 7 and 15 by 7. We got the coordinates of the point P. Friends, with this we conclude this chapter. I request you to please subscribe my channel, and if you really like the video, please give a thumbs up. This will motivate me to make more such videos for you. Thank you very much.